And here we are at the SID Display Week 2019. And hi, so who are you?
I'm Alex Hansen, working on making electrofluidic displays. We talked about this a year ago at SID. I showed a new development, which is a full color reflective display. We've made a few advances since last year. At this moment we're doing 25% reflectance with 70% of NTSC color performance, which is better than last year. And at the same time we're turning this type of display into a real active matrix.
What is this?
This is an active matrix display which is part of the display set. It's intended to be three-layer color display in cyan, magenta and yellow. We specially developed this TFT panel to be more than 90% transmissive. So actually in the open position, this is the yellow panel of the set. In the open position it will transmit 90% of the light.
So what do you want to transmit 90%? It means a brighter display?
It means a brighter display. So a total display should have a reflective backplane, and it has 3 layers of color, cyan, magenta and yellow. Every layer of color takes away a little light. And that means we have to reduce the amount of light that is taken away as much as possible.
So you do 90, 90, 90.
That's it.
So this is why you're down into 25 here?
Yeah, that's why we're down to 25 here. This layer, each of these layers only transmits about 80% of the light, and so that boils down to 25% total reflection. If you can get the 85% up to 90, it will go up to 50%. So very steep.
You get to 50. That means you get to twice as
bright as it, yeah.
Twice as bright, twice as vivid, the colors?
Yeah. The colors won't change much, but they will be brighter. And so that means the total color gamut volume will increase.
So since last year, what more do you have going on with the active matrix?
Well, last year we had a very simple active matrix display in black and white. And this year we have developed a 6-inch active matrix in full color. The only thing I can't do yet is to show it working, because we're still figuring out the electronics to get it to switch.
It's not easy? It's not just like using the active matrix or something else?
Basically it's easy, but if you make a design error somewhere along the lines, then it becomes a lot more difficult. And so we're now tuning the design error out and making sure that everything works properly.
So what is it that we see here? What is that?
The thing on top is actually a first attempt at a product. This is something that could be seen as a single pixel that can switch to any color that you want. It has a direct control of the red, green and blue channels, so it can display 16 million colors, 8 bits per channel, and it can be directly controlled by a DMX system, which is down here. And so in principle I can select a single color like yellow, the display turns yellow, magenta, the display will turn magenta. And so you can select any color you like, any brightness you like. So this is the first attempt at the product.
Giant pixels.
It's very, very early. Giant pixels. Actually, we link together millions of pixels to form one large area in this device. We can have a whole wall, yes. So
you just need somebody to place an order?
We're working with people to have a look at that.
Nice. And then it looks really awesome, right?
Yep.
When it's a whole wall. But then it takes all the sunlight?
It just takes the sunlight. It's just a reflective area which you can switch into either a whole region switching, or if you do your best you could make it into an information display by generating an image on smaller pixels.
So and these demos right here is also related to what you just said?
The glass you see down there, the colors are just an example of stacking the 3 primary colors, cyan, magenta and yellow, showing that you can make any color with just these 3 primaries. As you all know, but because it's in normal printing, you also use cyan, magenta and yellow inks to create a color image.
So
that's what we do.
You're convinced that the electrowetting is going to realize the dream future of...
I'm convinced that electrowetting can absolutely achieve a performance like more than 50% reflectance, so brighter than e-ink, in full color with the full color gamut that you can see now in printed color on paper.
And so do you have some students working on this?
Well, we're now developing this technology in a university. We have built a full-scale manufacturing line, but it's still manned by students and graduates. And so we're now trying to get the personnel together, the real manufacturing personnel, the engineers, to turn that from a prototype factory into a manufacturing line.
Can you introduce here at the booth? You have some partners right here.
Yeah, one of the partners is Morphotonics. We've worked for them to make a micro-replicated structure inside our displays to keep the two glass plates at a fixed distance from each other. And
hi, so who are you?
Hi, my name is Rob van Herve from Morphotonics, one of the co-founders. And Alex just presented one of the applications of our technology.
What are you showing here?
So these are some
Can you stand behind?
demonstrator samples. So we are in the business of the nano-imprinting and micro-imprinting equipment. So customers with the bright innovative ideas using nano features, micro features, that's all nice, but how to apply them on a larger area, large scale, cost effectively. So you need mass production tools, mass production
nano.
equipment. It's nano, these are nano features. What you're seeing here is an image of nano gratings or smaller features with a track pitch below 1 micron and certain sizes that are lighting up here as an example of our technology.
How is it useful for the display industry?
This can be scaled up to Gen 5 size that you can create nano imprinted features for holographic displays or autostereoscopic lenticular displays. You can have light guide plates with a better uniformity regarding your backlight, 1D local dimming, anti-reflective features on the front. And there are a lot of new ideas here presented at SID this year that all require micro and nano textures. But
Is this your machine?
this is now running 24/7 mass production in China. One of the first tools, this is a Gen 3 tool that is actively now for a mobile phone application.
What is it doing?
It's treating the glass. I'm not sure where we are in the movie, but it's treating the glass with an adhesion promoter. Then we copy features by coating a flexible mold. This is an example of a flexible mold. We use an inkjet printing system to apply UV curable resin on the negative texture on the flexible mold, and this is laminated then on any substrate like plastic, PMMA, PET, or display quality glass, 0.4 millimeter, 0.3 millimeter thick glass, that then has the opposite feature of the negative mold. So the positive features are then imprinted and they can be used, for example, holographic displays or any AR textures, VR glasses, light guide ink coupling features, whatever you need. That's not yet available commercially and on a cost-effective way. But until now, since 5 years, we have started Morphotonics, been a little bit in stealth mode, but we're now showing off our production equipment is at a mature enough level. It's proven in the field. The flex stamp can last more than 1,000 times, so 1,000 copies of a single flexible stamp. So you can have a very cost-effective way for high accuracy features.
So around here, the potential partnership that could happen here, how can this enhance this kind of display, for example?
Manufacturing technology should be there on a larger scale. That's where we can help Alex.
So nano is useful for
nano or micro is useful for our products. So in many cases, the technology of Morphotonics can replace photolithography. Photolithography is a very well-known process, but in some cases, certainly if you need somewhat higher structures, it can be expensive. Microreplication in that case is much more cost-effective in terms of material use. And then on the other side of the spectrum, in nanotechnology, there are other patterns that cannot be made by photolithography, in which case Morphotonics comes in again to produce these structures.
So you replace photolithography
Yeah,
somewhat.
yeah, certainly.
It's like a big challenge in the industry to do the lithography. Sometimes it takes costs a lot of money, or
Yeah,
you
yeah.
can make things simpler, or what?
Well, photolithography can still create a master for us as a starting point. Then we can copy from this quite expensive master and then replicate it very cost efficiently, even up to Gen 5, Gen 6, Gen 7 and beyond sizes. So it opens up a cost-effective application scene that now is presented to the world.